electric potential of a charge distribution given by the equation. So we have equation where x, y, and z are measured in meter and v is in volts. Calculate the magnitude of electric field vector of the position, whatever we have. So we're given the option either A, B, C, D. So what do they want? These people want, you need to pay attention to the equation, okay? Pay attention to the equation. What do they want? That's the most important. The magnitude of electric field. Oh, so to get magnitude of electric field, I need to have electric field. Let me get electric field. To get electric field is easy. So we say electric field. This is what is electric field I need to find. So how am I going to get electric field? Which will represent by E. You're going to have to find D, okay? D, V means differentiate this V with respect to X first. V with X, dV, dx. And then I. Remember when you talk about the magnitude, you deal with the vector now. And then with plus now, find dV means V with X means you differentiate with V with Y now. It was X, now with Y. And they say J, and then for the last one it could be dV, dz, and this is going to be K. Okay, so when you find that, and then it's going to be easy for us to get the magnitude. Because to get magnitude, so this electric field, to get magnitude, this is how we get it. Magnitude of whatever we have. You're going to have to take off of that vector equal to take this dV, dx, and then what you do, you square. That's how we get the magnitude of a vector. And then dV, dy, and then what you do, you square. And then for the last one, it's going to be dV, dz, what? Square. And then what you do, you put the square root. And remember, this magnitude of vector means is the length. Magnitude of a vector. Magnitude means distance or length. So whatever we're going to have, they say meter or which one? Is in meter. So it's going to be measuring for this case. Or you can say units, because this is a general formula. So if it's centimeter, we're going to say centimeter, meter, whatever we have. You know what I'm saying? So take your function and change it as electric field, but in a vector form. So now what we have to do, we have to find dV dx. dV dx is very easy, man. So we're going to say d, this is v with x, y, z. So dV dx means differentiate only v with x's only. So 3 times 2 equals 6, because you differentiate x's now. V with x. This is going to be 6x. Because if it's minus 1, and this is going to be y squared. So I believe you have an idea of differentiation for you to do this. You know what I'm saying? Okay, so this one is going to be 2, 6 plus y, and then we plus now dv with x. So we differentiate only x. There's no x's here. So since there's no x, means everything is going to x. The constant is going to be 0. Now we come here. When you differentiate this x, you get 1. So it's going to be minus 2zq, 2zq. You know what I'm saying? That's for x. Now, so it's minus. Plus and minus will be minus. So this is like minus. Plus minus give us minus. Now we want to go for dv dy. So for dv dy is easy. Means I want to differentiate with respect to y. So when you differentiate this, it's going to give you 2 comes back. It's going to be 6 x squared and y. But you take this number here minus 1. It's going to be 2 minus 1 equal to 1. So y power 1 is y. Now I come here and then we plus. Now we differentiate what? dv with y. Okay? So v with y, when I differentiate this y, is going to give you 1. So it's going to be 1 times z cubed equal to zq. Now we go for the last one. Now we differentiate only y. We don't have a y here. So everything is going to be 0. So because x is a constant. Now I go for dv dz. So dv dz, what happened? dv dz means we're going to differentiate v with z. V with z. There's no z here, everything is going to be 0. So when you come here, this 3 is going to come at the back, it's going to be 3yz squared. It's going to be 3yz squared, because you differentiate z, you know. So minus, now you come here, differentiate z, 3 is going to come back, it's going to be negative 6. And then it's going to be z. 3 minus 1 equal to 2, and then x. So we have already d, all of them. So another thing also I can do, since we have the value of x, y, and z, I can substitute here. So we get the actual value, you know, exactly value. What is exactly value? If you put here what is x? X equal to 2, so it's going to be 6 times 2. Okay, we can say here 6 times 2, and then times y. What is a y? Y equal to 3, and then square minus 2 times z. Z equal to 4, so 4 what? 4 cubed. So plug that in the calculator, and that's going to give you, plug in the calculator, that's going to give you 20. This is going to give you 20. Now you can plug it slow, but I believe it's going to give 20. Now let's go for the second one. So now we're going to 6. Okay, what is the x? X equal to 2 square, and what is the y? Y equal to 3, and then we plus z. Z equal to 4 cube. Okay, take the calculator, plug in the calculator. So plug in the calculator. Excuse me. This is negative 20 my code. That's a negative 20. If you plug in the calculator, the second one is going to give 136. This is going to give us 136. This is for dv dy. Now we go for the last one. Okay, so this is going to be 3y. What is a y? Y equal to 3, and z equal to 4, and then square minus 6, z equal to 4 plus square times x equal to 2. So plug in the calculator that one. When you plug it, it's going to give you negative 48. Plug it to negative 48. Negative 48, yes, negative 48. Okay, so we have already actual dv dx equal to negative 20, dv dy equal to 136, dv dz equal to negative 48. So what we're going to do, we can substitute and get electric field. And after getting electric field, we can get the magnitude. Because, you know what I'm saying? Now we go. So now let's get electric field. So electric field.